Hi everybody. So we're going to start back with the 2021 Math MCAS, and this is number 17. If you're taking this, or if you're watching this video, you should know that there is a digital version of the test available for you to do online in the format in which it was taken in the spring. So I would definitely recommend trying that first, and there's also a printable PDF that's also in the video description. Okay, let's get right to it. So as a candidate received 59% of the votes cast in an election. In the election, 76% of the 39,881 registered voters cast a vote. Which of the following is closest to the total number of people who cast a vote for the candidate in the election? And as you can see, I already underlined closest to. Closest to is important because that means we're estimating in this case. And you can tell by these answers, right? So we're going to be estimating here. Okay, so let's see what it's asking us to find. It says, which of the following is close to the total number of people that voted? So we want to know how many people actually voted. Okay. We know one candidate received 59% of the votes cast in an election. All right. In the election, 76% of the 39,881 people cast a vote. So I guess first we need to know how many people actually voted, and then of that number of people that voted, we need to find how many of them voted for that person, right, for that candidate. So we need to find this first. So, all right, if you didn't have a calculator, you could definitely estimate this. You could change this to 75%, change that to 40,000, and then find 75% of 40,000. So I'm going to do this two ways. I'm going to do this with a calculator and without a calculator. Okay. So I'm going to change this to 75% of. We'll change it to 40,000. And we want to change it as little as possible because the less you change, the more accurate it's going to be. So I'm going to change it to 0.75 times 40,000. And you can do that over here. 0.75, right? So we have 4 zeros. And 5 times 4 is 20. So then we have 4 zeros, 1, 2, 3, 4, 7 times 4 is 28. And we're going to end up getting, let's see, 1, 2, 3, 4, 5, 10, and there's 2 decimal spaces. So we're getting 30,000 people voted, right, roughly. So 30,000 people voted, and then of that, we're going to change it to 60%. So 60% of that would be how many people voted for that candidate, okay? So we're going to change it to 0.6 times 30,000, right? And it's going to be 30,000 times 0.6, or 6/10. So 1, 2, 3, 4. 6 times 3 is 18. It should be 1 decimal value. So it would be roughly 18,000 people voted for this candidate. Now, let's say you had a calculator. It's way easier. Well, not way easier, but it's pretty quick. So you'd say, okay, 0.76 times this. And so let's see how close we get here. 0.76 times 39881. That's that number. And then multiply that by 0.59. 0.59. And we get 17,882. So it's very, very close to this. It's much closer to that than 16,000. So yeah, that would be it. So I think this problem's more about, hey, do you know how to work with percentages, I think? And also just following this is a little weird because the order in which you get the information is different from how you're going to use it, because you're going to do 76% of this first, and then whatever number you find, you're going to take 60% of that, or roughly 60%. Okay, let's look at number 18. I think 18 is a two-parter. Yep. Okay. It's number 18. All right, this question has 2 parts. Consider the system of linear equations. See the system here. Part A, what is the solution of the system of equations? Enter the solution in the space provided. Enter only your solution. Okay, so there's a few ways you could solve this. You could use substitution, or you could use elimination. And either one is completely valid. I'm going to use elimination just because I like elimination overall for this particular problem. So I noticed that this is negative 2x. And again, there's multiple ways of solving this. I noticed this is negative 2x. So I'm going to make this become positive 2x. I know this becomes positive 2x by multiplying it by 2. So I'm going to rewrite that. So I'm going to distribute that 2 to all 3 of these. So 2 times x is 2x, 2 times 2y is plus 4y, and 2 times 8 is going to give me 16. I'm going to write the bottom equation without any changes. I'll zoom in a little better so you can see. And we're going to have negative 2x plus y equals negative 6. We're going to combine these together. These are going to cancel. We're going to get 5y equals 10. We're going to divide both sides by our coefficient, which is 5 in this case. And we're going to have y is equal to 2. All right, so we're not done yet. So we only have half our answer. 2 is our y value, right? So now we need to find the x. I'm going to plug it into the top one. So x plus 2y equals 8. I'm going to plug in 2 for our y value. So x plus 2 times 2 equals 8. That's going to give us x plus 4 equals 8. And then we're going to subtract 4 from both sides. It's our constant. And x equals 4. So our answer would be 4, 2. Zoom out a little bit so you can see all that at once. And again, you could solve that a variety of ways. You may have used substitution. You may have eliminated another variable rather than the x's. So, all right, let's look at the next part. Part B. We're going to graph the system of equations. So, all right. Now, the only issue with this is that these equations are not in slope-intercept form. So we're going to want to put them in slope-intercept form. And these are the very same equations we have here. Now, we know they should cross at 4, 2. That should be the point of intersection because that's the solution we found. So let's see what happens here. Okay. I'm going to rewrite this equation first. So x plus 2y equals 8. And I want to get y by itself. So I'm going to subtract x from both sides. I get 2y equals negative x plus 8. And now I'm going to divide both sides by my coefficient, which is 2. And this part kind of throws people off sometimes. Y equals, and I want to change that into a variable. I want to change it into a fraction. I want to have actually negative 1/2 x. So negative 1/2 x is the same thing as negative x over 2, but the way this is written would allow me to graph this. And then 8 over 2 would be 4. All right, so that's my first equation we're going to graph. And look, I'm going to do something really bad. I'm going to graph in pen. Although on the computer, you would just click on the points. So I'm going to put a point at 4 because it's my y-intercept. And I have a rate of change of negative 1 over 2. Let's make sure these boxes are 1s. They are, unlike that last problem we did before, which was awful, where the boxes were not 1s. So down 1 over 2. So down 1 over 2. And we're going to do that all the way down here. Now, you won't have to do this on the computer. It'll do it for you. You just need to plot 2 points. But by hand, it's most accurate when you do as many as you can. Okay. Do I have a ruler? I think I do. So here we go. So our solution was 4, 2. So this should be where they intersect because that's 4, 2. So the next line we graph, it should cross here. Let's find out what happens. Okay, so the other one's going to be negative 2x plus y. So I'll write that over here. So negative 2x plus y. Oops, hold on a second. Equals negative 6. So let's get y by itself. So we're going to add 2x to both sides. So y equals 2x minus 6. We're going to graph that now. So the y-intercept is negative 6. So I'm going to put that down here. Use a different color pen here. And then 2, so it's going up 2 over 1. So up 2 over 1. Down 2 left 1, down 2 left 1, up 2 over 1, up 2 over 1. There we go. Look, it crossed the right spot. Up 2 over 1, up 2 over 1, and so forth and so on. And let's go ahead and connect all these. Okay. And there's our point of intersection, which we thought it would be. Excellent. Okay, cool. I think we have time to do a few more. What time does this bell ring? This bell rings in 9:49. We've got about 9 minutes. So I think we can do a little more. Right, number 19. Number 19. All right, here we go. We'll probably just do one more. Okay, so Liam is a waiter at a diner. The scatter plot shows the relationship between the amount in dollars of a customer's check and the tip in dollars that Liam receives on an average day of work. Okay. Based on the line of best fit for the scatter plot, which of the following is closest to the tip that Liam should expect to receive for a $25 check? Okay, so the check amount is the X value and the tip amount is the Y value, or the functional value. So the check is 25 bucks. So these go up by 2s, right? So 20, 22, 24. So this would be 26. So 25 would be in between them. So 25 would be right here. So if I go up, this is the line of fit, right? And we want to know what the tip amount would be. So now we go to the Y value, or the functional value, and be right about here. So it's between $4 and $5. Okay, it's not quite 5. It's more than 4, less than 5. So any of these that are between 4 and 5. Okay, only one of them is between 4 and 5. 450, and that'd be our answer. So it's a matter of so there's a few things that's tricky about this one. One, they're not on one of these grid lines here. It's in between 24 and 26, and the 26 isn't labeled. So some folks, when they do this, they're going to think this is 25, and they're going to go up and they're going to say, okay, that's close to 5. They'll do 5. So you have to be really careful. The MCAS is a way of taking something that shouldn't be super tricky and trying to make it complicated. And this is a good example because you're interpreting a line of best fit, but because of the way the grid is set up, that is going to confuse some students, and I bet it did when they took it. Okay, so that's going to be, do we have time to 20 to see how complicated 20 is? Yeah, we'll say this one next time. So we're going to stop there at 19. I hope that was helpful, and see you soon. Bye.